The recording software is ready now, so I'm going to just share my screen and then we'll start. All right, screen. Okay, so I believe you can all see my screen now, right? Can anyone confirm if you can see my screen? Can you people hear me, or I'm just speaking?
The screen is visible.
Okay, and okay, all right, no wahala. So we'll just start now since the screen is visible and everyone can hear me. Then we'll just proceed. Let me confirm my mic is on. Okay, yeah, it is. Go back to my slide and then put it on full screen. Yeah, so you're welcome to today's session. So, like I said, today we are going to just digress a little bit to discuss an important fundamentals of cybersecurity, which is networking. So, like I said, it's very important because the whole cyberspace is built on a network. Okay, you'll get to understand that when I go into the definition. Okay, so let me just go straight there. So what is a computer? What is a network? So a computer network is a system that connects two or more computing devices to transmit and share information. So just like I said, the cyberspace in which we are all operating now is built on a network. So network is the backbone in which this cyberspace is built on. Okay, so network is when you interconnect one system with two or more system for it to be able to transmit or connect or share information. So I'll give you an example. So you see, when you're trying to share a file on your phone with another phone, maybe through Zenda or any other sharing application that you do, the first thing you do for you to be able to make sure you're able to send that particular information or for you to be able to share the resources that you do what you network them together, and this is what you do when you connect your two devices. So you choose one of the app as sending, you choose it on the other app as receiving, and then with the use of some protocols which we are going to talk about, with use of some protocols, the two devices are going to connect. Okay, the two devices will connect wirelessly, and then you will now be able to transmit. You'll be able to share your file from phone A to phone B. So that is just a simple definition. That's just a simple explanation of what the network is. But for the cyberspace now, so now what you did in your Zenda is that you connect just your phone and another person's phone. So that's just you connect two devices. But more than you can connect up to 100 devices for them to be on the same network. You can connect billions of devices to be on the same network. The reason you can hear me now where you are is because we are all connected on the biggest network in the whole world, which is the www, which is the internet, the world wide web. We are all so the internet is the largest network, okay, in the whole world because it connects. If you are connected to the internet, you can be able to ping any device that is online. You can communicate with anybody. If so far you have the right applications, the right resources, maybe you need airtime or you need to have data, of course, and then you need to have maybe the address of the person you want to contact. In this case, maybe you are calling him on WhatsApp, you need to have his phone number. So that is what a network is. So organizations, they all transmit their information above the internet, everybody. And then also another type of network is what we have, the one we use for our mobile phones. We can see that before you can use your mobile, for all of us that are still a bit, I won't say we are old, but we saw the GSM revolution. Before your community can be connected on the GSM network, they will bring a mast, right? No, I know a lot of people grow up to see mast in their area. But for those of us that are opportune to see when they were being mounted, you see that before you cannot, even if you have smartphone, you have SIM card on your phone, you cannot connect. But the network provider will bring their mast, they will install it, they will put all the things that they are expected to put on it for you to be able to make calls, and then we can all see that we are now able to connect to the device. So that's just what the network is in a nutshell. From you connecting two phones via Zender and sending information to them, for you connecting maybe two computers together wirelessly, or you use cable to connect them. So that means you have been able to establish network. And the purpose of network is for you to be able to transmit data, or for you to be able to share information, or for you to be able to share resources between these two devices in which you communicate or more. So that is what networking is all about. Okay, so we'll go into the purpose of a computer network, which I have talked about a bit. So you can connect. You can decide to have a computer network, or you can decide to have network due to different reasons, right? One of the reasons you can choose to have a network is resource sharing. So network allow users to share resources like files, printer, internet access, and it helps to reduce cost and improve efficiency. So let me just give a brief explanation of that. So we know before we used to have what we call cyber cafes, right? And when we go to cyber cafe to browse those days, you see that they have like maybe 10 computers, just one printer. Okay, so with the network allows you to be able to use what we call a network printer, where you are going to have in maybe with the cashier or whoever is in charge of the cafe, and then it doesn't matter which system you are using, so far the system is connected on that network, they are on the same network. You can share, you can send your file to the printer, you print it, and then you go and get it. So this is still being practiced in organizations today. If you are opportune to work in an organization where there's a network, you can see that your printer can be anywhere, maybe in your manager's office or just in an open office. You can be able to send your files to the printer and go and pick it up in where that particular printer is located. For those that work in banks, maybe customer service, or all these SMEs or small organizations, you might have seen this, or you must have seen this, as the case may be, right? So network allow us to do what we know as resource sharing. So you can have a single resource, and all the computers can also share it, right? So I just use printer as an example. It can be files. You can have a centralized system that we call a server on the network, where some important files are located, and then all the systems on that particular network can access that particular server. So this is just an example. The another thing the networks allow us to do is for us to be able to communicate. So we are having what we call a video conferencing now, because I'm here speaking to you from I'm in Kaduna. Some of you are in Lagos, some of you are in Ilorin, some are not even in the country, some are in Dubai, anybody can join. So far you have this link, anybody can join and be able to listen to me and see this video, that I see this presentation I'm currently sharing. So that is another way that network helps us. It allows us to communicate. You can communicate through email, through Insta messaging, through video, which I just explained, and every other way. And then it also helps to facilitate collaboration and interaction. So we can see now that people work remotely. You can be in Abuja, your colleagues can be in Lagos, your colleagues can be in Anambra, your colleagues can be in UK, they can be in Canada, and then you can work together. You can work on a proposal, you can send it to them, they will review it, send it back to you, then you work on it, and you may not even see each other till you die, and you'll be able to work together. So network also allow us to be able to do that, right? So another thing network allow us to do is what we know as centralized management. So network allows what we call a centralized management. It's become easy. So for example, for an organization like bank, which I've been using as example before because it's something we can all relate to. Their head office is in Your head office can be in Lagos, and then the IT team can all be in Lagos, right? And from Lagos, they can be able to manage all the applications in the bank, in the bank remotely, right? From Lagos, they can be able to create username for new staffs. If a new staff resume in Kano today, or if a new staff resume in Zaria today, you don't need to go to Lagos to get your username and password. They can be able to do that centrally from Lagos. They'll be able to create you, and they'll be able to generate your user account. You'll be able to log in. They can also you can also maintain your system, do updates if you have issues. They can help you remotely. So networking also helps for us to achieve what we know as centralized management. So your IT team can be stationed in one place, and your staff can be scattered all over the country or all over the world, and then they will still be able to do whatever they need to do as if they are physical. So also the network also grants us access to information. So we have what we call you can be through the airport, through the internet, you can have access to different websites. You can read on anything, you can access anything, you can go to online database to search for anything. So far you have access to it, you can go to for we have database that give you information for free, like Wikipedia and the likes, and we have database that you need to pay before you get information. Okay, we have news platform, we have the ones that are free, we have the ones that you have to subscribe for you to be able to for you to pay before you can have information to those, you can before you can have access to those information. But it's made possible through network. Okay, through network. Internet is also an example of a network. Okay, and also of course entertainment and gaming. We can all watch people play game online. For some of us that are video games enthusiasts, you can play your maybe PlayStation, Xbox online through the use of internet. You can play with your friend that is abroad or in another location. You can play together. You can stream using Netflix, Showmax, YouTube, and the likes, another form of entertainment. So network allows all this. So these are just some of the things network can do. There are others that will be, the time will not permit us to mention. So type of network. There are actually I just added VPN to this so that because it's one of the things I mentioned yesterday, and it's one of the reasons we're having this class. So that's why I add VPN to this. Usually you only see these first three when you are talking of type of network. So we have usually three main type of networks. Okay, there are others. Okay, but they can all fall under these three. Okay, so VPN, I just like I said, I'm just the one that added it to this so that I can talk about it so that I will not forget, because I don't want to forget. Okay, so we have what we call a local area network. Local area network is like the smallest set of network. It can connect maybe just two systems, or maybe 10 or 100 depending on the location. You can be typically a house, an office, or a school, maybe a school library or a computer lab, where you just connect some systems. They are all in the same location, they are all in the same room. You connect them together with your, mostly LANs are used by you connect them with cables. So we get to that, we get to the type of connection. I have it somewhere in the slide. So local area network is in a limited area, right? It's in a very limited area, like an office, house, or a school. Most likely a school library, or maybe it's a small school. It can extend to different offices, but it can still be a small school. I mean, maybe like a secondary school where it's just like one building or two buildings that are not too far apart from each other. So you can still refer to it as a local area network. So the next one that should follow it is the metropolitan area network, which is actually the third one. It should come second here. So this covers a larger area of network than a LAN. So it can span across a city or maybe a community. For example, the university community. For example, our universities are usually large, or polytechnic. For those of us that are opportunity to attend school, we see that our campus are usually very large, right? And then it's possible for you to put all the offices in the campus on a single network, right? On a single network. So you can use wireless device. So we'll talk about the types of, so you can use cable in some places, you can use wireless in some places, and then you will ensure that, but notwithstanding, the whole institution will still be on the same network, right? So that is what we call the MAN, which is the Metropolitan Area Network. Then the other one is the Wide Area Network, which is where you connect device over a geographical distance, often using the internet as the backbone. So you can connect. So the wide area network is when you connect when the location is not a barrier, right? So you can decide to connect with the internet. You can use satellite. You can use fiber optic cables and the likes, right? So that's the wide area network. And then the VPN is also, VPN can be is it's usually fall under the wide area network, and it creates, like I said yesterday, it creates a secure tunnel over the public network, like I said, which I just mentioned now, which is the internet, and then it allows remote users to connect securely to a private network, right? So that is how a VPN works. So a VPN creates a secure tunnel. It creates like still over the internet, but it creates a secure tunnel where someone that doesn't have access to the VPN will not be able to access the resources on that particular private network. So remote users can connect to that particular network using their VPN credentials, and then they will connect, and then they will now be able to have access to those things that is on the private network, right? So another thing VPN can do for us, just like I said yesterday, is that the VPN can also allow you to be able to, bypass some protocol. It can let you change your, maybe your location, like depend on, because there are different type of VPNs and different application of VPN. So I'm supposed to actually have two images here, but I don't know why one is showing here. So this is usually a general use of a VPN. Like if you are using it for maybe you're trying to use it to access the internet. So you can see this is our user device and this is the internet. Okay, so there's what we call a VPN client, which is what you install on your phone, right? So you see you can download the VPN. We have different types of VPN. Some are free, while some you have to pay before you use them, right? So and then your VPN, you first connect to your first establish connection to your VPN client, which is on your phone. Okay, and then it's now send an encrypted communication to your internet service provider. Okay, and then your internet service provider allows you to now connect to what we call the VPN server. So the VPN has a server somewhere, and which allows your client, which is the one you install on your phone, to connect to the server, and then the VPN server will now reroute your access to the internet, and then you can now have access to the internet. So this is how it works typically, and this is why it helps us to, for example, when Twitter was banned, or if any service is banned in your country, you can actually use VPN to pass to do it. Another way VPN is applied is in organization. So now, instead of this general client that you have, it's going to be the VPN client your organization provides to you, and then the VPN server is going to be the VPN server your organization is using, and then that is now going to give you access to the VPN resource, which normally you cannot have access to if you are not using that particular VPN client. I don't know why the image is not here, and I don't want to go back online to look for it, but that's just typically how it works, right? So it's just typically the same thing. The only thing that is different now is this VPN server now, which is going to be your organization private server, and then it has a VPN on it, right? So this how a VPN works. All right, so that's that about VPN. So another the disadvantage of using a free VPN is that whatever you do on that free VPN, anybody can, even hackers can design VPN. Okay, it's just a protocol. It's just for them to design it and give you free access to it. But the bad thing is that this server can be able to see whatever you are doing. So that's why it's important to use, if you are going to use a VPN at all, that's why you see organization pays good money, as in they pay serious money for them to be able to have access to VPN services, right? Not the one we just download for free. Organization pay up to thousands of dollars annually for them to have access to VPN, right? So that's just on the side. So now we'll now talk about so VPN now gives us ability to access what we call an intranet. So we are going to talk about the two now. So we have internet and we have intranet. So internet is what we are. I don't think I should waste too much time on explaining internet. We all know internet. Internet is what we are on now. It's the vast global network of interconnected computer networks. So it's just the web, the World Wide Web, that is connecting all of us together. So that is internet, and then it's publicly accessible to everyone with an internet connection. So you have internet connection, maybe on your phone or your laptop or your tablet, you can be able to access the internet and any other information that is available on the public network. Okay, so to provide access to amount of information, blah blah blah, then it's generally less secure because it's open in nature, and then it requires you to protect yourself as an individual. It requires you to be a responsible user of the internet for you to now be able to protect yourself on the internet, because anything can happen, right? And like I said, so we are going to get to encryption, where you see the difference between browsing. It's where I tell you some other things, but right here, just know that the internet is less secure, and it requires you as an individual to be responsible for your data protection. Okay, so then we have the intranet. Where's my intranet slide? Wow. Aha, my intranet slide is missing. Maybe when I duplicate, I just delete it. But notwithstanding, I will send, when I'm sending the slide, the updated one will be there. But I'll just explain intranet. So the intranet now is still vast, right? But it's more like a private network where organizations share their data, they share their information across to their staff, to their employee, right? So that's where they make use of that VPN I explained previously. So it's still it's still relying on the internet, but due to the implementation of the VPN and some other controls, it's only going to be open to employees, people that have access to it. So you connect to the VPN, it gives you access to the information on the private server of the organization. And for the intranet, it's more secure than the intranet in terms of security. Okay, in terms of accessibility, it's not publicly accessible. For you, for example, now I cannot from here access the intranet of, let's say, GT Bank, Zenith Bank, Etisalat, Nine Mobile, rather MTN, all these corporate organizations, CBN, NNPC, and the likes. They all have their intranet, which they use. Okay, but it's only their employee that will be able to access it with the use of their VPN client and their private VPN server, which they are using. The purpose is still to provide information to access, but to the access of that particular organization, not the general access in this case, and then it's more secure. So that is what is on that particular slide. But I must have made a mistake in deleting it, right? So the next thing we are going to talk about is network devices. So network device are device or equipment or systems that are able to connect to the internet. So we'll not waste too much time on this. So we have our computers, our mobile phones, our tablets, PDA, whatever, all fall under this category. So some people call them endpoints or whatever. So, but the thing is, you can refer to them as computer here. So it can be your laptop, your desktop, mobile phones. So they are like the device that we normally interact with. Then there are devices that we call router in a network, right? So router they are like the traffic controllers on the internet. So what we mean by traffic controller is that just like I said, traffic is how information is being sent across the network on the network. So routers are responsible to make sure that they direct. For example, you are trying to send something to trying to send a mail to to I'm trying to send a mail to the CEO of a particular organization, right? So router makes sure that when I send that email from my email, it gets to the person I'm sending it to. So that is the work of the router. So it say when the message comes in through the internet, how I wish I can do. There's this video I would have loved to show us, but I couldn't find it. Or maybe when I get it, I'll just share it in the group of how the internet works. So when the message comes in, the router inspects it with the headers, what we call the header of that particular message that comes in, either email or whatever the packet is. It inspects it, it locates the address where that particular information is made for, and then it forwards it to that particular individual that the message is meant for. Okay, then there's what we call the switch. So the switch direct data within a specific network segment. So the switch is like so the switch is if you have been in a network setting, right? So let's say for example you have 20 system in your organization, right? You have like 20 systems that you want to connect. Okay, so you can buy the switch have different port. You have like 12 port switch, you have 24 port switch, you have 32 port switch, depending on how large your organization is, and you can use more than one. So the switch is now what you now connect all your systems to. Okay, you use the cable. What we have what we call a twisted pair of cable or LAN cable, as the case may be, or Ethernet cable. You connect them to your system or your computer, and then you connect all of them to one single switch. So the switch now serves as the central device that now puts all those computers on the same network. So you can now, if your computer are now more, you can have organization that have more than 10 switch, 5 switches, depending on how large the organization is. So you can now connect the switch. So when you connect the switch together, they are still on the same network. So I will just, all these things I'm mentioning, I'm going to send illustration so that when you see it, it makes more sense. And then of course, I also spoke about firewall yesterday, which I said is the security guard of the internet. So it's the same thing here. So it monitors your incoming traffic, it monitors your outgoing traffic, then it filters them based on predefined rules that you have set in the organization. So this helps to protect you from potential threats and also to protect the network. So it can block information from coming into your network, and then firewall can still block information from going out from your network, right? So depending on the rules that you set, so the firewall does that for you. And then we also have what we call the modem. Okay, so these days modem are not as common as they used to be in the days where we have our VSAT and the likes. Now you don't really need a modem per se. Okay, for example, now organizations can just buy an IP net, all these broadband that we are using, SpectraNet, IPNet, or even Starlinks, as the case may be. So it now combines the functions of a modem and a router. It now combines that function. So when you have all these IPNet, and you're like, even our MiFi that we use, okay, our mobile MiFi, you can still refer to your MiFi as a router. Okay, yes, if you have a MiFi, you can refer the way the big routers work is the same way our MiFi is the same way they work. And for some MiFi, you can see that even if you go to your setting, you can see that there's a firewall on your MiFi, which can allow you to block access to some websites or to some things that you don't want to have access to, and it can also allow you to block devices that you don't want to connect to your MiFi, as small as it is. So all these things are now being incorporated into into a single device, right? So if you are thinking of modem, if I want to explain modem now, the best way to just say modem is your MiFi that you're using. So that's like a modem and a router combined. For small, but for large organization, they have their router separate, they have their firewall separate. Okay, so that's just a quick example. And then now we now talk about cable. So we have you can connect your computer in two ways. Either you use network cable or you use wireless. Okay, so there are different type of cables. Okay, so I don't want to go into the details. So that's why I didn't break this down. This is networking is a complete course on its own. Like it's a course that you have to do for like 6 months or 3 months before you get to understand everything. So I'm just trying to give us an high level understanding of all these things. So that's why it's not very, very detailed, right? Just for you to have an example, just for you to have a foundational understanding, and then you can do further reading or depending on where you want to specialize on. But we have what we call network cables. Okay, the most common that you see these days is our twisted pair, which some people call the LAN cable now, or some people call it the Ethernet cable. So that's the one we normally see in our cafe or in offices, where you have a slot in your system where you can put it. I'm going to also send a picture of that. I know it's something that you've seen. It's something that a lot of us have seen. It's very common. So that's what we call the twisted pair. They call it twisted pair because the cable come in 4 pairs. Okay, that's 8 cables. 4 pairs. Yes, 4 pairs. A pair is 2, right? Yes. A pair is 2 cables, so it comes in 4 pairs, which means a total of 8 cables is inside it. And there's a way you have to configure it for it to work. You can do it manually or you can buy it ready-made. So that's, like I said, that's another course on its own entirely. And then we also have what we call fiber optic cables, where we see people digging the road. I'm sure we've also seen this before. You see people digging road, laying all these yellow cable, green cable, red cable in our roads. So that's what all these organizations or telecommunication company are using to send their network or to interconnect different cities in the country. So you see, we have a fiber optic cable, or a submarine cable rather, comes from abroad. I think we have like 3 or 4 now in Nigeria. We have main one in Lagos. I think one landed in Akwa Ibom recently that the Minister of Communication mentioned recently. Okay, I think we have like about 4 or 5 submarine cables that has landed in the country. And then telecommunication providers, they pay to this service provider, and then they connect using their fiber optic cables to now interconnect to stay. So you can see they have that's why you see manhole, so that the engineers can go in to manage those cables. So those cables that we are seeing that they are laying, and fiber optic cables are quite very expensive. They are expensive and they are very fast. They comprise of glass. It's used glass and light to send information or to transmit data. So it's super fast. It's very fast, and that's what most telcos are now using to interconnect different communities. Okay, so that's that about cable. And then we have what we call our wireless adapter. So in wireless adapter, they will use radio waves to transmit data through the air. So they replace network cable. So just like I said before, you can now connect your 2 phones together without connecting it with wire, right? You can send something from, before, if you want to send something in the olden days, even before the Bluetooth comes, you have to connect your phone maybe to the system, you transfer it to that system, then you now use another cable to connect to another phone, then you copy it from that system. So that's what we used to do before. But now you can just use wireless to connect 2 mobile phones together or 2 systems together and then transmit information. So the same thing in organizations, we can have what we call routers and wireless routers now, just like the one we all have, most of us now have, that we buy from MTN, and the likes. So that's an example of a wireless router. And then other example are all these radios or access points that we see around in all this organization or building where we can have access to internet with them. So they connect them, they deploy internet on them. There's a way they configure them, and then you can now transmit, you can now connect to it and then transmit information or data across the network, right? So those are the two common ways uh, communication work. But for the wireless, you still need to use some form of wire for you to now be able to maybe extend it or deploy your internet to that particular network. So all this, like I said, are things that we may need to go into details for them, but that's not for the purpose of this particular class. But it's something that we'll also consider going forward. And then the other thing we are going to talk about, though protocol is, I don't know why I even put protocol here. So protocol is not supposed to be here. It's not under network device. So please, when you are reading, or maybe I'll remove it before I send it and put it and take it to the next slide. So protocols they are like language, just like you can understand me now. I'm speaking English, you understand English. So that's why we are able to communicate. Okay, so if someone that is from Cameroon or someone that is from Togo in this class now and has not been to any English speaking nation, you'll see that that person will not understand what we are saying. And if someone should come into this class now and start speaking French, many of us will also not understand. So that is what protocols are in the network. So protocols is like the language all the device in the network speak. So if there's any problem in protocol, there will be error in communication. So because all the devices have to connect, for them to be able to connect, they need to speak to the same language. And that same language is protocol. So protocol defines how device communicate, ensuring that information is formatted and understood in a consistent manner. So we have different type of protocols depending on the network, on the type of network, if it's wire, if it's wireless, if it's GSM, if it's 4G, 3G, 5G, whatever. They all have their protocols, which is standard, which all vendors have to comply to. If you don't comply to that protocol, your device will not be able to connect in the network. So protocols define the format, timing, and meaning of data exchange between devices. They are like predetermined instruction that specify how device should how device should connect. So protocol help us to establish how device are to connect, establish and maintain a connection. Okay, then protocol also help us to also help device on how to format data, how to break down. So for example, if you are sending, for example, if you go into your web browser now and you put www.facebook.com, okay, so the computer does not understand www. I'll just give this just an example of formatting data. I'm just trying to see. The computer does not understand www.facebook.com. It doesn't understand it. Okay, but there's a protocol now that will now say, okay, there's a protocol which we call a DNS, domain name service, or is it domain name system? That one I'm not sure. Okay, but what that protocol does now is that it's now it's like the DNS is what we call the phone book of the internet. Before we used to have phone books. Okay, before we now start having smartphones, when we used to have landlines, or the time where we used to have all these 3310 and then like where they can't take more than maybe 100 numbers, and then you have like close to 300 numbers. So what we do usually that we have a book where we write name and phone number, because it's not easy for us to cram all the numbers in our head, right? Humans find it difficult to cram numbers in our head. So the same thing applies on the internet. Internet only understand numbers, mostly binary. The internet understand one and zeros, binary numbers and stuff like that. So, but because if you want to go to Facebook now and I start telling you to put 10.168.212.4 before you get to Facebook, nobody will remember it. Everybody will forget, right? So that's why we now have what we call a DNS. A DNS, like I said, is domain name system or domain name service. Not sure, but it's either of the two. So what it does is that www.facebook.com that you type into your web browser, the DNS converts it to numbers, right? Convert it to what we call IP numbers. IP numbers, I don't know why I don't have IP number in this my slide. I'm talking about network and I'm not talking about IP. So IP number is like the address for every device that is connected on the internet, either a computer, a server, a website, a phone, whatever, it must have an IP. Okay, your phone has an IP address. Your system have an IP. Your phone have an IP has an IP address that was issued to it by your telecommunication, by your ISP rather, by your internet service provider. It has an IP address. Either it's static or it cannot even be static. It's going to be dynamic. It's going to be allocated by your IP service provider. In this case, it can be MTN, Glo, Airtel, Nine Mobile, Spectranet, Smile, depending on the one you are using. So that's like the address. So the same thing with server and websites, they all have the IP address. So the DNS now break that particular www thing that you send it in a format that the system understand, and then that's how you'll now be able to see the information on that particular website, and then you'll now be able to see it. You'll now be able to see it. So that's just what it means by formatting data, and then transmit data. So also when you are sending email or when you are sending message on your WhatsApp, it's a protocol that take the message from your phone and take it to the other person's phone. There's a type of protocol that do that. When you're sending a file from your Xender from one device to another device, there's a protocol that is being used. Okay, and then there's also what we call error correction. Okay, so protocol is also allow us to do what we call error detection and error correction, because there can be collision when you are trying to send information. Okay, so protocol help us to detect this error and then help us to correct it. For example, when you are viewing a website, right? When you are viewing a website, if the network is good, if the network is bad, you see that it slows down, and then it can show it in a format, a jackulu format that you don't understand. Maybe some things are missing. So when that particular protocol that is in charge detect that something is not wrong, it try to refresh, and then you now see that the website, when the network is good, then you now see that the website is now coming up the right way it's supposed to come. So that is a protocol that also handle that. And then when you are streaming something online, you see that it buffers, right? And then if it's a live streaming, and when it buffers, it's just the ones you have missed, you discard them, and then it takes you to the updated one that is currently streaming. So that is also a protocol that allows you to be able to do that. And of course, security, for you to now be able to put all these, you go to your Wi-Fi, your modem, you set your, what we call it, the password of your modem, right? So that someone will not be able to log into your modem and use your data or something, or the same way organization do it, whereby when you go into an organization, even though they have a wireless network, there's a password on it. So it's also a protocol that allows us to do this. So protocol works in layered approach. So we have the key protocol, or the most popular protocol, or one of the most important protocols which we all use every day, is what we call the TCP/IP protocol. So the TCP/IP protocol is IP is internet protocol, and is responsible for addressing and routing data packets across network. So just like I said previously, I didn't talk about IP address separately, but this has addressed it. So each device on the internet, just like I said previously, has a unique IP address. So it's just like your house number, maybe number 306 Ibrahim Taiwo Road, Kaduna, number 40 Ibinkpedu Lane, Idumota, Lagos, all those things. It's just like IP address. So just like I said, your phone has an IP address presently. The computer that you are using has an IP address. So whenever you connect to the internet, your ISP assign an IP address to you dynamically. But there are some cases whereby you need to use what we call a static IP address, where the IP address does not change. There are situations that warrant that, which we are not going to be talking about those two today. But if something that interests you, I'll advise that You can go and read them. So the purpose of actually doing this is just for us to have this understanding, and then we'll be able to relate to them when we get to see them subsequently as we proceed in the course of this study. So like I said, this is just like us taking a step sideways, or this is just like a digression for us to be able to understand more. So then another popular protocol is the TCP protocol. So TCP is known as Transmission Control Protocol, which manage the reliable transmission of data between devices. So it breaks down data into packets, ensure they arrive in the correct order. So just like I said, and request retransmission. So just like I said in the website, I used an example before. If the network is not good, or there's an error in connection when you are trying to access a website, you get to see that the website automatically refresh itself, and then it's where if it has shown in a format that is not good, or maybe when you refresh it, it comes again and then it comes up in a proper order. So that is the work of a TCP. So you can just think of IP address as your postman that delivers data packet to the right address, and then TCP makes sure that that particular packet gets to the right address in which you are trying to send it to. So the TCP is like the quality control officer. It ensures that the packet gets to their destination, right? So there are other type of protocols in network. Like I said, there are many, more than they are in hundreds, if not up to thousands. There are different type of protocols. So we'll just talk about the most popular one, HTTP. HTTP allows us to connect on the website, but it's not secure. It sends information in plain text. So that's why when you see any browser, that's why we tell you that if you see any browser that you are trying to access a website and there's no padlock on it, you see that it will tell you that your connection is not secure, and you are not advised to share anything that is sensitive on that particular website. So that's why you see it's HTTP. Okay. So another one is DNS, which I've explained before, which translates domain name, which I said is the phone book of the internet. So the DNS translates your numerical IP address. So our IP address into numerical IP address, which the computer can now understand. So like I said, it's just like a phone book for the internet. Then FTP is file transfer protocol. So that's the protocol when you are sending a file, across the network. That's what protocols like Xender uses. That's a protocol applications like Xender use, or maybe when you are sending a file from one computer to another computer. And then we also have SMTP, which is for email. We have other protocols for email. This is not the only protocol. Then we have HTTPS, which is the secure version of HTTP that comes with the padlock. So there are other ones. There are UDP. There are many that I can't even call on my head now. So there are different type of protocols that you come across, but this is what they all do. They all have one or two things that they are doing. So we can do further research on that to be able to understand the different type of protocols. Then the last thing we are going to talk about today is ports. So port is like a number. It's like for example, when you send a mail, when you send a letter to PO box, for example, in advanced countries, I know we used to have this in Nigeria before when we were much younger, or many of us did not even grow up to see it work properly. But before, when they bring a letter, for example, in a house whereby it's a big house, or let's say university, for example. So if you have to send a letter to someone, in Department of Cybersecurity in FUT Minana, you're going to use the same PMB 65 that the school is using to send the letter to that school, right? So that is where you're sending it to, and then you have directed it to Department of Cybersecurity, and then you also put maybe the name of the person and the depart and the level with that person is. So that's the port number. So port number is the specific, it's like the specific number for that particular application you are trying to access on the network. For example, if you are trying to browse on a system, right? I said you are using HTTP, you are using HTTP. HTTP is for accessing the internet, or HTTPS, right? Which is which is HTTP. That's the normal one. But there is a port. So when it comes in, so when an HTTP traffic is coming into the network, it has to follow a port. It has to the port. It has to follow that particular port. So that port is like a door or a window, which the traffic will go through. So for HTTP now, the port number is usually port 80. Okay, I think that's the only port number I even know in my head. I think port 80 is the only port because they are there. You can go and check it online. They have a whole lot of them, a port number. But the only port number, because I'm not good at keeping numbers, right? So that's port 80. So whenever you see anything that is directed to port 80 or port 8080, you know that okay, this is an HTTP request. So that's what the port is. So let me just so just like I said now, so just imagine a large apartment building with numerous residents and business, and each resident has their own apartment number. So what if they all receive deliverables at the same door? So that's going to be a problem. So that's why you make sure that even though you are sending it to the same address, which is the address of that large apartment, you still have to know the apartment number in which that particular message is going to. So that is what the port is. So they are dedicated doorways for specific application on a device. So each port is assigned a unique port number ranging from 0 to 6,000, 65,535. When data arrive at a device, the port number tells the OS which application is to route it to. So, like I said, most of this application, all these applications that we've been mentioning, all these protocols that we have been mentioning, they all have the port number in which they operate on. So that when we are now telling you, when we get to security controls and I'm telling you to close unused ports, and we have not had this class, you'll now be wondering what is port, what is unused port. If I'm telling you of security protocols and I'm telling you of maybe HTTP, TCP, explaining TCP handshake, and then you don't understand it because there's no so you can see why it's important for us to have this class. So this is how so just like I said okay, so good, very good. Like I said, I know only port 80 offhand, which is your HTTP port. So when you visit the website, your browser send a request to the web server on port 80. So if your port 80 is closed, if someone closed port 80 on your system now, or on the server you are trying to access, you'll not be able to have any access to any HTTP server. So if your organization wants to stop people from browsing, but the disadvantage of this is that you stop port 80, nobody will be able to access anything on the web browser. So, but you can change it. Also, some people change it. It's also possible for you to change the port number, but when you are changing it, you have to make sure another application is not using that port number. So it's only people that are actually going to do network security that need to pay more attention to this. To be honest, if you're not going to be in network security, you may not need to know all these things, right? So like I said, so there are different port numbers. Secure protocols like HTTP use port 443. Email use port 25. This is the standard port for SMTP. Telnet have their port, SSH, different things. They have all these they are different port numbers. So this is how all this, so like I said, this is going to be the last thing we're going to talk about for this particular class. So there are other things after doing this slide that is missing, and the most important one that I observed that is missing is our OSI model, right? It's also very important. It's very important we understand the OSI model. So what I'm going to do is that since I've been the one talking, I've been the one taking this class. So what I'm going to do is that I'm going to send a material on OSI model to the group. Okay. I know it's something that even some people that are in the industry, they find it difficult to understand. but I just want us to do it in the hard way now. So we've seen all these things that we have learned, all these protocols. Now you come across them in different layers. So what I'm going to do now, I'm going to share all the material on OSI model. We'll go through it. Then by next week, I will not be the one to speak now. So on next week Saturday, you all will now be the one to speak on what you have learned on OSI model. Then if I'm okay with what I with what I understand for what you are saying, and then whatever you say, don't let me say if I'm okay. Either I'm okay or not. I know there will still be I know some people who still need some form of clarity. So next week we are going to on Saturday the participants will be the one to tell us based on the material I send what they understand by the OSI model, and then on Sunday I'm now going to reteach the class on the OSI model, and then I'm going to answer all the questions that you may have on OSI model, and then every other thing that you don't understand based on what we have done so far, and then we'll now continue the week after that. So that is how I think we should do it, because it's very important. If you don't understand all those OSI model, uh, you will still find some things difficult to understand as time goes forward. So I believe it's very important to talk about those model, and then okay, if we are able to finish on Saturday, I also want us to talk about, like I said yesterday, we are going to also look at common threats, vulnerabilities, and mitigations for them. So I want us to also look at that, so that we'll get to understand things like ransomware, virus, Trojan, worms. I know some people will understand this, some people know this already, but some don't, or some do, but there may be some form of confusion between them. So I also want us to have a class to explain all these things: phishing, social engineering, man in the middle attack. It's not as if we are going to do them or password attack and stuff like that. We're just going to explain what they are and how they work. So hopefully next week let's use Saturday for OSI model, and then we use Sunday for this thing. So we are going to break the Saturday class into two. You are going to first tell me what you understand. The class is going to tell me what they understand by the OSI model, and then I'll take it. Then on Sunday we'll look at all those common threats, attack, vulnerability, and mitigation, and then we'll now continue with our class the week after. So this is going to now bring us to the end of our session today. So if there's any question, we can now ask. If there's any question based on what we have said today, you can ask, and then I'll now provide my answer to it. So thank you all for listening, and then I wait for your questions. Thank you. So please, if you have questions, now is the time to ask.
My own question is, thank you for the class. Something I don't really understand before. I feel like this is the best time to actually ask the question.
Yeah.
What sort of network or connectivity does infrared use? I think we stopped using it actually, but
Yeah.
it's still something I feel I want to.
Okay, yeah, infrared is actually one of the earliest form of wireless network. Okay, but it's called a line of sight network. Why we call it a line of sight is that the two devices, you see that there's like a small indicator or bulb. Can I call it bulb? I don't know if I can call it bulb, but it looks like a bulb on top of both devices. They have to point to each other
Yeah.
before you can now establish communication. But it's not wired, because there's no wire that is connecting the two devices. It's still wireless, but it's called line of sight communication, because those two bulb must be facing each other before you now be able to establish the communication. But it's still wireless either way, but it's line of sight, and it's very close range. If it's far apart, it will not connect.
Yes.
Yeah.
Thank you.
All right, yeah, you're welcome. So, any other question? All right. So, if there's no other question, and then I think we can end this class now, and then by God's grace, next week Saturday we are going to continue. So, thank you all once again for attending. I'll be looking forward to see you all in the next class.
Thank you very much.
Thank you.
Thank you very
Mr.
much.
Nathan. Yeah, thanks. I'm surprised I don't have question for me today.
Yeah. No. At least I'm enjoying the whole process.
All right, no wahala. All right, thank you. It's nice to have you here. All right, good night, everyone, and see you next week. Yeah, bye.
Good night.
Yeah.